Okay, guys, this is going to be one of the most important things that we do in Trig. I mean, literally, this will be the basis of what we do for a good part of this unit and a good part of the next unit. And it goes back to our good old 30, 60, 90 triangle. So if we just think about our good old 30, 60, 90s, when we did those back in geometry, opposite the 30 we had box, opposite the 60 we have box root 3, and the hypotenuse was 2 box. We're going to make this very simple because what's trig? Trig is ratios of these sides. So we're going to make this easy, and we're going to make all the boxes 1. So if I come back here, really, this just becomes opposite the 30 is 1. We're going to make this as easy as possible. Opposite the 60 is 1 root 3. We don't need to put the 1 in there. And the hypotenuse is 2 times 1. So same thing with the 45, 45 triangle. This is normally box root 2, but instead of box, we're going to put in a 1. So it's going to be 1, 1, root 2. So this is a very important template, as is we continue to use all students take calculus to tell us what quadrants each trig function is positive, what quadrant each one is negative. So we're going to find the reference angle. We're going to use our 30, 60, 90. So we're just going to get right into it here. I'm not going to mess around. So the first one, sine is my favorite. I'm going to start with sine. I'm going to say sine of 225 degrees. Always draw a picture. 225 degrees, that's a positive angle. So I'm going to start here and I'm going to rotate. I'm rotating up 90, 180. I'm not going to get all the way to 270. So that tells me I'm in the third quadrant. So this whole arc is 225 degrees, but we know this is 180, so I'm going to subtract 225 minus 180, and that's how I'm going to get a 45-degree reference angle. So I draw my triangle, always out from the origin to the x-axis. The reference angle is 45. So reference angle is 45. Always the reference angle goes to the x-axis. This angle here, yes, that is also 45, but we don't care about that angle. We only care about the angle that goes to the x-axis. So I'm going to get rid of all this. We won't normally have all that in there. We're going to get good enough to get rid of all that. So now I say, okay, it's a 45, 45 triangle. I'm going to use my template. 1, 1, root 2. So the sine of 225, sine is opposite over hypotenuse. So opposite of the reference angle is 1, and the hypotenuse is root 2. So this is going to be 1 over root 2. And when I think all students take, only tangent and cotangent are positive in that quadrant. So this is negative. And of course, we're going to rationalize this. So my answer is going to be negative root 2 over 2. That's what the sine of 225 is. This is all non-calculator, So draw the picture, find the reference angle, draw your triangle, and go. Find that ratio. Don't forget about all students take calculus. So let's do secant of 330 degrees. Right away, you should pretty much know what quadrant it's in. So I know that that's between 270 and 360. So I know I'm here in the fourth quadrant. So I'm going to just immediately, I'm not going to necessarily draw this. I don't need to do that because I know I'm in the fourth quadrant. So I'm going to draw a triangle. Out from the origin to the x-axis. I just have to figure out this reference angle. So this is where you think, if this is 330, how much more do I need to get to 360? So I'm subtracting from 360. 360 minus this 330 is going to be 30 degrees. That's my reference angle. Always to the x-axis. That's the angle that we care about. Yes, this angle is 60. We don't care about it. You're always going to add and subtract either from 180 or 360. You never use 90 and you never use 270 to figure out your reference angle. Never. Let me say it again. You never use 90, you never use 270 to figure out the reference angle. You're either subtracting from 180 to get a second quadrant answer, adding 180 for that third quadrant answer, or subtracting 180, or you're subtracting from 360. Okay, we'll practice more of that. All right, so now I label my triangle. Opposite the 30 is 1. Opposite the 60 is root 3. Notice I don't even need to write in the 60 here. I don't really care. My reference angle is 30. Hypotenuse is 2. So secant. Secant is the reciprocal function of cosine. So I'm going to think of cosine here first. I'm going to say, what's the cosine of 330? Cosine is adjacent over hypotenuse. And then I'm going to take the reciprocal. So when I write it here, I'm going to write 2 over root 3. Then I'm thinking about all students take calculus. Cosine is positive here. Secant is the reciprocal. Our answer is going to be positive. And then we rationalize that. So I multiply by root 3 over root 3. Simplify that. And my answer is going to be 2 root 3 over 3. Positive answer, positive ratio. All my answers here are ratios. This is a ratio. This is a ratio. The angles are here. And these are not quadrantal angles we're working with right now. Quadrantal angles, you don't draw a triangle. You do your X, Y's, and R's. These are using our special 30, 60, 90, 45, 45, that kind of stuff. Okay, let's try tangent of negative 150. I draw my picture. Negative 150. So let's think about what quadrant that's in. I'm starting here because it's a negative angle. I got to go down and rotate. So I'm going to go negative 90. I'm not going to go all the way to negative 180. I'm going to come back. So I'm in the third quadrant. I'm going to redraw my arc. So that would be my negative 150. I'm going not all the way to negative 180. So you got to think, what is this reference angle here? Well, I just like to say, well, how much further is it to 180? It would be 30. Reference angle is going to be 30. Ignore the negative. Just think of this as 150. In geometry, we need another 30 to get to the 180. Or you're thinking of this whole 180 angle, subtracting the 150. So again, I really don't need this. Once I figure it out, I'm going to draw my triangle. Out from the origin to the x-axis, reference angle is 30. I guess I've done a 30-degree angle here. Oh, no, I did a 45. So opposite the 30 is 1. Hypotenuse is 2. And that's root 3. Tangent is the ratio opposite over adjacent, which is going to be 1 over root 3. All students take. I'm positive, so this is going to be a positive root 3 over 3. Of course, I already rationalized it. I multiplied by root 3 over root 3. Okay, so all of these, 30, 60, 90, 45, 45. Number 4. Let's do cotangent of 120. 120. I'm thinking to myself, I know that's between 90 and 180, so I'm going to be in the second quadrant. I'm just going to draw my triangle out from the origin to the x-axis. This angle is 120, so the reference angle, I have to figure out what is this angle right here. Again, I'm either thinking, well, if I go all the way, it's 180. 180 minus 120, 60 degrees is my reference angle. Opposite the 60 is root 3. This is 1. Hypotenuse is 2. I don't like cotangent, right? We don't like cotangent. We like tangent better. So I'm going to think about what is the tangent of 120. Tangent is opposite over hypotenuse. So you can either think this is hypotenuse over opposite or just find it here and then we'll flip it. So opposite is root 3, not hypotenuse. Did you catch that as I was doing that? Opposite over adjacent. Root 3 over 1. All students. This is going to be a negative answer. All students take calculus. Only sine and cosecant are positive in the second quadrant. So this is going to be a negative. I'm taking the reciprocal of this. Root 3 over 1 would be for tangent. This would be 1 over root 3, and of course you would rationalize that again. So it would be negative root 3 over 3. That's my final answer here. It's negative because it's in the second quadrant, and cotangent is negative in the second quadrant. Okay, last one. Well, I'm only going to do 5. I'll make this quick. Let's do sine of 450 degrees. 450 degrees. Let's get a coterminal angle. Since it's bigger than 360, I'm going to subtract 360 until I get an angle. Oh, I get a 90-degree angle. Draw my picture. 90 degrees is right here. Out from the origin to the x-axis. Can't draw much of a picture. What am I going to do on this? It's not a triangle. This is unit circle. Unit circle. So I'm thinking x, y's, and r's. This is x, this is y, this is r, which is always 1. So I think, okay, here's 90 degrees. So I'm up here. What's this ordered pair? It's 0, 1. On that circle of radius 1, that radius is 1. A little bit of oblong circle there, but the radius is 1. So you can either think of sine as being opposite over hypotenuse, or remember, why do I sin? Because of my x's. Sine is just the y value. What's the y value in this ordered pair? 1. Answer is 1. Again, you could say it's y over r. Our y value is 1. Our radius is 1. So I wanted to kind of remind you of that, not trick you, but remind you, quadrantal angles, go to this triangle. Remember, this is always your x, this is your y, and this is your radius. Okay, so now you're going to try some of these, see how it goes. This is the guts of the semester right here, people, or I should say the guts of trig right here, because we're not going to have a whole semester. All right, until next time, stay safe. You guys make sure that you keep asking me questions if you need it. I'm going to probably put up a link, if I haven't already at this point, of how you can chat with me, okay?